Hey everyone, and welcome. Today, we're jumping right into a really important topic for your AQA A-Level Psychology course, the biological approach to explaining obsessive compulsive disorder, or OCD. We're going to ask a big question. Is it all down to our genes and brain chemistry? Let's get into it.
So this is the massive question, right? Can something as complicated and, as personal as OCD really just be boiled down to our biology? Well, the biological approach says, yeah, pretty much. It argues that the roots of OCD are physical. So let's see what kind of evidence they've got to back that up.
All right, so here's the plan. We're going to tackle this exactly how you'd want to for the exam. First, we'll build up all that core knowledge. That's your AO1. Then we'll see how to actually use it, which is where you get your AO2 marks. And finally, we'll get critical and evaluate the whole thing for those top-end AO3 marks.
Okay, kicking off with our AO1 knowledge. So the biological approach puts forward this pretty big idea. OCD isn't just something in your mind, it's physically rooted in your body. The thinking is, yeah, a stressful event might be the trigger, but the actual vulnerability, the predisposition, is already there hiding in your biological makeup. So if there's a vulnerability, where's it coming from? Well, the first place psychologists always look is our DNA. Let's dig into how our genetics might play a part in passing down a risk for OCD. Now, to try and untangle that whole nature versus nurture puzzle, twin studies are the classic go-to. And the logic is actually super clever. If a disorder like OCD is really genetic, then you'd expect to see it pop up way more often in identical or monozygotic twins who share all of their genes compared to non-identical or dizygotic twins. And what do they find? Well, the evidence is pretty powerful. A big review by Nestad found that if one identical twin has OCD, the other is more than twice as likely to also have it, compared to non-identical twins. That's a really significant difference, and it gives us some strong correlational evidence that genes are involved.
And researchers have even started to zoom in on what they call candidate genes. Think of these as specific genes of interest. Two of the main ones are the SERT gene, which is involved with serotonin, kind of like our brain's mood manager, and the COMT gene, which deals with dopamine, a chemical that's linked to things like motivation and repetitive actions.
But, and this is absolutely crucial for you to remember, there is no single OCD gene. It just doesn't exist. As research by people like Taylor points out, OCD is polygenic. So don't think of it like a single light switch that's either on or off. It's much more like a massive sound mixing desk with hundreds of tiny sliders. Each individual gene just nudges the overall risk up or down a little bit.
Okay, so genes are one part of the puzzle, but how do they actually do anything? Well, they provide the instructions for building our brain. So let's move on to the second part of our AO1, the brain itself, its wiring, and its chemical messengers, and how that might lead to OCD. So when we talk about brain chemistry and OCD, two neurotransmitters pretty much always steal the show, serotonin and dopamine. The main idea is that it's like a seesaw that's out of balance. On one side, low levels of serotonin are thought to lower mood and dial up anxiety. At the exact same time, high levels of dopamine might be pushing those repetitive compulsive urges.
Now let's look at how this might play out in the brain's wiring, in what some people call a worry circuit. It's like a faulty feedback loop. So step one, the front part of your brain, the OFC, which acts like a worry detector, gets stuck in the on position and sends out a constant alarm. Step two, normally a little structure called the caudate nucleus would filter out silly, unimportant worries. But in OCD, it's like the filter's broken. The alarm signal busts right through. Step three, this signal then slams into the thalamus, which is kind of the brain's action center. It goes into overdrive and creates this overwhelming urge to do something. And that, of course, leads to step four, the compulsion. And the tricky part is, performing the compulsion provides a brief moment of relief, which actually reinforces the entire broken circuit, making it even stronger next time.
Okay, that's a ton of theory. Let's make sure we lock in those AO2 application marks. Because it's one thing to know this stuff, but you have to be able to apply it. Let's see how these ideas actually work in the real world. Take a look at this scenario. We've got a teenager who develops OCD during a stressful time. What's the clue here? The family history. Her mother and grandmother having similar symptoms points towards a possible genetic vulnerability, a diathesis. The huge stress of exams then acts as the environmental trigger. It's a perfect example of that diathesis stress model. And what about real-world treatments? This is a huge application point. Think about it.
Drugs like SSRIs, which work by increasing the amount of serotonin available in the brain, are often really effective at treating OCD. Well, if adding more serotonin helps reduce the symptoms, that's pretty strong practical evidence that a lack of serotonin might have been part of the problem to begin with.
And here's a tip for getting into those top mark bands. Always try to make links to other parts of the course. You could connect biology to the behavioral approach. You'd say the anxiety has a biological origin, but the compulsions become learned behaviors through negative reinforcement. Or you could link it to the cognitive approach. Maybe biology creates the initial intrusive thought, but it's the person's distorted, catastrophic thinking that gives that thought its terrifying power. Right, time for the all-important AO3 evaluation. This is where you put on your critical thinking hats and really weigh the evidence. So, how solid is the biological explanation when you really scrutinize it?
Let's start with the good stuff. This approach has some serious strengths. It's based on objective, scientific evidence, right? Things you can measure, like genes and brain activity from scans. And, as we just said, it has fantastic real-world application. The fact that it's led to effective drug treatments that help millions of people is a huge plus point. That's the A for applicability in your GRVA evaluation. But, and there's always a but, we have to be critical. First, most of this evidence is correlational. We see a link between brain activity and OCD, but we can't be sure which causes which. Does the faulty circuit cause OCD, or does having OCD cause the changes in the brain? That's a big problem for its validity. Second, it's just not a complete explanation. If OCD was 100% genetic, identical twins would have a 100% concordance rate, and they don't, not even close. This proves that other factors must be at play. And finally, you can criticize it for being reductionist. It tries to boil down a very complex human experience to just neurotransmitters and genes, ignoring how our thoughts and our life experiences shape us.
So, after all that, what's the bottom line? Let's pull everything together into a nice, balanced conclusion, just like you would at the end of a top-scoring essay.
The final verdict? Well, biology clearly isn't the entire story, but it does seem to be a massive part of the foundation. Really, the best way to think about OCD is with the biopsychosocial model. It's like biology loads the gun by creating a vulnerability, but it's psychology and our environment, our thoughts, our behaviors, our life stressors, that actually pull the trigger. So I'll leave you with something to chew on. If OCD is so deeply rooted in our biology, what does that mean for things like therapy and personal willpower? Where do they fit in? It's a really deep and fascinating question that gets right to the heart of how we think about mental health today.